Today we're going to be talking about the probabilities of mutually exclusive events. So we first have to define some terms. So mutually exclusive. Mutually, each one of them are exclusive of the other one. So the two events can't happen at the same time. The two events cannot have the same outcomes. So said another way, I think of a deck of cards. So I draw a card, and it is a king or a 5. A card can't be both a king and a 5. Versus not mutually exclusive. They're going to share something in common. So both of the two things have something in common. So I draw a card, and my card is a king, or it is red. Okay, and I'm using a keyword there, and I didn't even realize I was using it. That word or. And when we get to our probabilities, and we're looking at the word problems, if you see the word or, that's going to be meaning that we're mutually exclusive or not mutually exclusive. Okay, so determine whether each event is mutually exclusive or not. And it's kind of funny that I picked cards and then my example has cards. So Han draws a card from a standard deck. The card is an ace, or a 9. So can an ace be a 9? No, it can't. So they are mutually exclusive. Okay, not mutually exclusive. Okay, so a king or a club. A king can be both you can have a king that is also a club. Remember, you have 3 suits. You have a club, spade, hearts. Why am I forgetting the last one? Diamonds. Okay, so those are your 4 suits. Club is a type of suit. There's one king that is also a club. Okay, so these are not mutually exclusive. Okay, so probabilities of mutually exclusive events. So mutually exclusive events is when A or B occurs. That key word in there is or. So again, I want to highlight that. That's or. So when you have probability of A or B, we add our probabilities together. Remember, when our keyword was and, when we had independent and dependent events, we multiplied. So our example, Trevor reaches into a can that contains 30 quarters, 25 dimes, 40 nickels, and 15 pennies. So let's look at the total amount. So if I add all those numbers together, and I'm going to do it quickly. I don't know why I don't trust my notes. I just did these problems. There's 110 coins. Okay. Probability the first coin he picks is a quarter or a penny. So that or, again, that tells you I'm going to be adding. So you do the probability of your quarter. Probability of my quarter is 30 plus a penny. A quarter can't be a penny, so that's why these are mutually exclusive. I add these together, I get 45 over 110. Notice how I didn't reduce my fractions because it becomes easier for me to add, and then I reduce from there. Okay, so mutually exclusive events, if they don't share anything in common. No, if 2 events are not mutually exclusive, so they share something in common. So king and a red card. Okay, you take the probability of A, probability of picking a king, probability of B, picking a red card, and you subtract the probability of A and B. You subtract the probability of red kings, because you've counted red kings in this probability and this probability. So you counted that probability twice. So you have to subtract it out once. Okay, let's do an example with this. So my example here, using the table below, what is the probability that Namiko selects a watercolor or a landscape? So again, I have a watercolor or a landscape. Do I have paintings that are watercolors and landscapes? Yes, right there. So I'll tell you right now, this is kind of a chart. And this is like, I could see where this could be confusing. This is the number of each one. So the number of watercolors that are still life, portrait, landscape, that's a total of 12 things. If I have a total of, under oil, I have 3, 4, 5, 6 things. I have another 6 things. And I have another 6 things. So here I have, if I add all of these together, I have a total of 30 paintings that we're looking at. So I pick probability of a watercolor. My dad draws watercolors. So probability of a watercolor. Probability of a watercolor. I have 12 total watercolors. I add to that the probability of a landscape. So a landscape, I have 3, 4, 5, 6. So I have 11 landscapes. So I have 11 out of my 30 paintings are landscapes. Now you've counted this 3 basically in there twice. So you need to subtract it out. You need to subtract what's common out, because I've combined it in this probability and this probability. So again, don't reduce your fraction because it's easier to add those fractions. 12 plus 11 minus 3 is 20. When I reduce that, I get 2 out of 3. Okay, probability of a complement. So probabilities of something happening and something not happening add up to 1. Does that make sense? It can either happen, can't happen. So they have to add up to 1. So the probability of something not happening is 1 minus my probability of it happening. Okay, so a not is going to be sometimes a lot easier to find if we do 1 minus the probability of it actually happening. So here, in this example, Miguel bought 15 chances to pick 1 red marble from a container to win a gift certificate to the bookstore. There are a total of 20 marbles. What is the probability Miguel will not win the gift certificate? Okay, so my probability of not winning is equal to 1 minus my probability of winning. So 1 minus my probability of winning. So my probability of winning, he bought 15 chances out of 200 marbles that he's going to pick. So that is 185 over 200, or 37 over 40. And we could really look at probabilities as percentages. So when I divide this is a 9 that's not right. When I put this as a percentage, his probability of not winning is 92.5%, because I put that as a decimal and then I multiplied. I moved my decimal place over 2 spots. Okay, so probabilities are really, you can think about them as percentages too. Okay, this is his probability of not winning. That's actually a pretty high percentage. I wouldn't have thought it would be that high. Anyway, okay. Now this one gets me every year. Not gonna lie. Gotta be honest with my students. So a survey of Kingston High School found that 63% of students have a cat or a dog for a pet. 2 students are chosen at random from a group of 100 students. Okay, good. We're 63 out of 100. What is the probability that at least one does not have a dog or a cat? So at least one means that the first doesn't have a dog, the second doesn't, or both don't. Okay, that's a lot of probability to find. That's why it's easier if I find the probability of both having the pet. So 1 minus the probability of both having my pet is going to be a lot easier to find. Okay, so let's talk about the probability of both having a pet. The probability of both of them having a pet is, out of 100 students, said that 63 have a cat or a dog. So that's 63. Then we've taken away one person. They have a pet, so it's 62. So this ends up being 217 over 550. And I multiplied that together in my calculator and reduced. So I find the probability of them not having, of at least one not having, so 1 minus this 217 over 550, and that is 333 over 550. And that ends up, just so you know, that is 0.61. So 61% chance of at least one of them not having a pet. Actually, that seems pretty high too. I don't know. Math is what it is. All right. Okay, so that was your probability of mutually exclusive events. Thanks for watching.